All right, we're back. We are COMP1004. That's Rapid Application Development in the winter 2017 semester at Georgian. And we are week 3, part 2 of our broadcast. We're still dealing with this little calculator issue. Some people have issues. I also went around with talking about your user interfaces and the lab 1 stuff. Things of note when you do your user interface. In this case, we're just doing a calculator, but if you're doing a user interface where you have space around your buttons and controls, make sure it's the same space. I try and put the same space around everything. So if you have I like to call it like almost like a space cushion around your user interface, make sure that there's the exact same margin around everything, okay? Try and make your controls line up where you can. Some people I see are using some kind of table layout, that's fine. But sometimes table layout can be constricting. So only use it when you need to in different areas. Like for example, this is not part of my table layout, right? This thing here, right? It's not part of it. And I did that on purpose because I know I'm going to move it around or do something else with it, right? There's something else I want to add today. I want to add a picture box because that's one of the things I asked you to do on your little assignment, right? So here's my picture box on my assignment. Notice that it kind of hugs the top. Now my layout is such that it kind of doesn't hug. I don't have any kind of borders around my layout or very, very similar, smaller ones. So if I'm going to add some kind of image that goes in here, because I want to kind of add a calculator image, you know, I talked about a logo. I'm going to make a little, you know, dummy logo here, right? How big is this, right? And I want to ask you some questions about user interfaces. So here's an opinion. And we're kind of diverging from coding for a second, right? Because I'm still designing a little bit of my user interface. Opinion 1, it's better to have the computer calculate the size of the image for you because it can align to your picture box. That's opinion number 1. Here's opinion number 2. It's terrible for the computer to assign or stretch the image for you because it has to work hard from a calculations perspective to render your user interface. Which opinion is the right one? First one, the second one. Think about it, right? So if I let the computer do the stretching and squeezing for my images on the screen, right? In other words, it does it through some kind of code, right? It's bad. The other one is, yeah, it's okay because then that way it's okay for the computer to stretch. What do you guys think? Which one's better? One can skew the image. Yes, right? What about image creation? Like, do you think you should have predefined images for your UI? They're already pre-created and just attach them in at the right size? Because remember, we are doing an absolute layout here. At the end of the day, we're not doing a stretch layout. We're not doing an adaptive layout. This layout is absolute. It's going to be exactly the same size. And that's the answer I was looking for. The answer is the opinion that the computer should do stuff for you and stretch and squash with code is incorrect in most cases from a user interface. And the reason for that is because it takes cycles, computer cycles or CPU cycles to render means draw the image to my user interface, right? So what I want to try and do is pre-do my image ahead of time and not stretch it. And if I got to pre-do my image, what do I need to know? My space. What kind of space do I have here for my image if I'm going to use this whole space? If I'm going to use it. I'm going to do it here just because. But if I'm going to do it, I need to know the size, right? So scroll down to the size of your image. Notice that I need an image that's around or very close to 299 by 91. Now, if you're smart, right, you want to kind of round these off, these values, as much as possible. And if I look at my form, I can see that the form, remember we talked about the form being a certain size? I asked you to make it 320 by 480. That means I really do have 320 pixels wide, but I can't fit this whole thing on here. I can't make it too much wider. I mean, I could do this, but that kind of makes it look weird, right? It's kind of stretching right to the edge. And if I look at the image now, from a size perspective, it's 317. It's still, you know, smaller than the form, but it's like looking like it's stretching the whole way. How come? Because the image itself includes a bit of margin. That's why, right? Built in. And you can see that here because of my padding. There's padding that's built in here, right? And margin. Padding is 0 for the image, but margin is 3. That's internal margin, not external margin, right? Which means I'm losing 3 pixels points from each side. That's 6. So even though it's 317, it's actually, you know, 323, right? It's actually larger than my image size, right? And I'm showing you this because this is a problem. Of course, to fix this, I could take away the margin, make it 0, 0, 0, 0. I can make it more, 2, 2, 2, 2. If I want to make it more, I can change the value so that it balances the way I want. If I was leaving by default 3, 3, 3, 3, that means I'd have 6, 3 on one side, 3 on the other. What's the maximum width of my image if it's going to fit in 320? 320 minus 6, right? Which would be 314. That's the largest size I can make my image. So let's make that 314. So let's say 314 by 91 for now. 314 by 91. Okay, good. Now, here's something. Where does it start, right? Notice it says the location is -8 and 2. What's that -8 and 2? What does that mean? I'm positioning, right? What does -8 mean? X and Y. This is where we go back to X and Y coordinates. Notice that the X coordinate, and this is local to the form, right? The top left corner of the form is 0. That means that this image is slightly off to the left of the left side of the form by 8 pixels or 8 points. If I made this 0, 0, 2 means 2 down, right? If I made this 0, 0, so I made this 0 and 0. I mean, again, this is absolute positioning, so I want you to see what this looks like. We still look like we're off. How come? Because the form itself has a margin of 3. That's why. So actually, we're not just losing 3. We're losing 6 on each side, right? 6 on one side, 6 on the other, and 6 on the top, right? You got to know these things when you start positioning things. Yes, you could do things by eye, right? But when you want to make an image that's the right size, you have to really kind of figure out what's happening here. So if I lose 6 on each side, 6 and 6 is 12, I really can make an image maximum of 308. Let's do that. So let's go back to my image size. This is 308 by 91, and comma 91, right? Now it looks like I'm kind of within. Again, right? Kind of looks like I'm kind of within. So I got a little bit of border on the side and this left side. I'm starting out the left side, 0. It's pushing me to the left, right? It looks almost like it's centered. Okay. 91. Do I really have to make it 91? And do I really have to make it 308? Right? What's a better number to make it? 300 by 90, right? 300 by 90 might be the best way because it's easy for me to set it up. It's nice and even. I recommend just like rounding it off. Easier for you to create an image that's 300 by 90, which means I have to center it within my screen. It's going to be slightly bit smaller, but it's okay. 90, you're not going to notice 1 pixel difference, really, right? And from a positioning perspective, remember what it's going to try and do is help you trying to position as much as possible. Here's a trick that I would use. Align at least one side or the other with one of these forms. Like, for example, here's this thing here is my table, and I want to align this one with my table, so I can always go to the left and align with my table. Now they're perfectly aligned. Right? You can't see the difference, but they are. Okay, we're good. We're ready to go with the next one. And the way to test this, of course, notice that there's a little smart arrow on top of here. This smart arrow says normal, right? And this is where I want it to stay. Once you change this from normal to auto size, center image, or zoom, now you're dealing with computational stuff where it computes where or and how your image is going to be drawn. So I want my image to be, again, 300 by 90, right? That's what's going to go in here. And I can use Paint, and I can use any kind of other program to create this image. I'm going to use kind of a Photoshop Lite that I like to use called Fireworks, or any other kind of program that's out there for free. There's also Krita, if you like the Photoshop replacement. And for Illustrator, there's something called Inkscape. So any one of those programs are free, but I'm going to use Fireworks here. So I'm going to go File, New. And with Fireworks, or with Photoshop, or with Illustrator, you can do something like this. I can say I want an image that's 300 by 90, exactly. There's my 300 by 90. I can scope in there. That's going to be my size of my image. So I can scope in there. This is what I want to draw. I definitely want to put in some kind of interesting background, and I can do that if I want to make a white background or a red background or a gray background or something that makes it more interesting. I can do that by going to Canvas, Canvas Color, and changing the canvas color to whatever I want. This is just color the background whatever I want. So here's my custom colors. Sometimes I like a nice blue, light blue color, something like that. If I press OK, bam, I got a blue color on my background, right? This is not an image. There's not a box here. This is actually the background of the canvas, right? Now, by default, I'm using a PNG image. And by the way, if you're programming with iOS or Android, PNG is preferred. Why? Because it has a transparency channel, an alpha channel, right? And it's not a bad idea to use those because sometimes you want to layer one image on top of another. Yes.
Do you use vector images?
You can. It's a good practice as well. They're a little bit more challenging to use if you don't know how to do it, but yes. But if they're scalable, that's the thing. Vector images are for scalable. I'm not making a scalable image here. I'm making a fixed image in an absolute format, right? Absolute layout. Yes, you can use all kinds of images. I think it'll support vector. So let's say SVG. It'll support PNG. It'll support JPEG. It'll support a bunch of other kinds as well, right? Please don't use RAW. That would be very bad. It's too heavy. But otherwise, it supports. Now I want to put some kind of text in here, to kind of talk about my little calculator. So this is my calculator, right? If you want to be, spectacular, you can use some kind of different kind of text. Now this is what it's actually going to be like, right? So I'm actually putting some text. This is going to be rendered text. So it's going to be an image. It's not going to be typed text, right? Because this way I have more control. And I don't want to choose, if I don't want to choose Arial, I want to use any kind of text I want. Like for example, I like Helvetica Neue, right? So I can make that. I can also make this all lowercase if I want, just to be flashy, right? I don't know. So even the calculator itself, right? Or I can make one character a different color, right? So let's say, for example, I don't know, I want my character style, so my fill style for this character. I want it, instead of being white, let's make it something like red. I could do that, right? So a calculator, right, to make it more interesting, right? I can also make it bigger, right? So it kind of fits the entire screen and kind of centers it. Again, I don't want my calculator to be on the left, right? So maybe I want to make it so it's much bigger. Right now, from a point size perspective, this is 34 points. Right, this is real life point size. So let's say I want to make it something like 50, right? And now the great thing about Fireworks is it gives you kind of center guides to kind of center this thing automatically just by eye, right? Which is kind of cool, right? And if it doesn't look centered, it's because I've got a big. Notice that the baseline of my font is really huge. I could reduce that as well. So I could kind of say, and again, if you look at some of these controls here in Fireworks, it enables things like, if I kind of hover over them and see what they are, right? There's my leading, right? That's what it's called. And so if I can reduce that, I can pull that down to, let's say, 100. Let's try 100. Yeah, I didn't really do it. Undo. And kind of bear with me while I do this. So I'm going to make sure it's correct. And this doesn't go down. That's okay. This is letter spacing. So if I want to space my letters out a little bit, I can say, well, my spacing is going to be like 20 pixels or whatever. I can do that. So I can space them out. So it's a non-standard looking font. It doesn't have to be the same. So it's kind of more spaced out than normal, which means I have to rebalance where it is. Notice now that's the center, right? Calculator. And some kind of interesting image in the background, like, I don't know, some kind of block or something like that would be nice, right? Or some kind of, I don't know, whatever else you want. I notice I have some control of some basic polygons and so on. So here's a polygon. Now notice it's my polygon. Maybe I want to put it underneath my C again. So I'm thinking about some kind of polygon that looks like this to make it more interesting, right? And again, this is just to make it so that it's not nice and easy. I want to put this color, and let's say instead of red, I want to make it some other color, like maybe we'll make it black. This is a contrast, and we'll send it backwards, so it's got a different arrangement, right? So something to make it interesting. And if it doesn't look interesting, you can always modify after, right? It's not a big deal. Like if I want to make this stretch or squash or make this a little bit differently sized, I can do that. I can kind of reduce it so that it fits just my C, or most parts of my C, right? So I'll keep doing it until I kind of scrunch it in there, right, to make it more interesting. The calculator with a little bit of and it kind of fits okay. And I can use my arrow keys to nudge it a little bit where I want to. And I can also rotate this if I don't like the rotation, because it kind of looks weird, right? So let's say I want to rotate so that's more of a hexagonal shape. I can do that as well by clicking this button and coming to the side here on the corner, and I can kind of rotate this a little bit at a time. That looks not bad. Kind of pull this over a little bit. If I want to make a separation between the C and this one, I could add a phantom character in there. So I could kind of do one of those. I could change the size of this font so it's a little bit smaller. This is a cheat. So I can go something like, instead of it being 40, I can make it so it's 20 just for this one part, or even less. Pull this right down to 0. You can also go negative. Lots of control here. And again, you don't have to, this is not this kind of course. But the great thing about it is that you're able to pull this in so it's not as drastic. There we go. That's still too much. So I can always undo that. Again, you can use this. You can use anything you want. I can also change the size of my font. My size is 50. Maybe that might be better. Let's change the size of my font to like 20. Yeah, it's better. Maybe even 18. The space is 18. So see what I'm doing? I'm just artificially changing the size. Okay, it's not bad. Calculator. And then now that I have this, I can always move this aside to rebalance some of that stuff so that it's it's more interesting. Is it a great font, a great logo? No, hell no. And is it balanced? I don't think so. I think I probably still want to move it down a little bit. So I'm probably going to select everything. And just from an eye perspective, move it down so it's kind of centered, right? If you really want to, you can put a border. I'm not going to put a border. I'm going to save this thing. So File, Save As. And I'm going to put it on my desktop for now so we can see it. So here's my desktop, and I'll just call this calculator logo. Well, calculator log. Okay, I'll fix that. And then what you can do is, right, and this is with any program, so forgive me if I'm doing this and it's boring you, but the reason why I want to do this is because, like I said, we're talking about rapid application development, and one of the things we need to do when we make this kind of design, I'm just going to copy this thing. I'm going to bring it over to the Windows side of the house, right, which is this side, and paste it here for a second. Here's my pasting. Now I also have I may want to put a directory for COMP1004. I don't know if I have one here right now. Yes, I do. Here's my directory, but I don't think I have all my files in there. I have some other stuff in that I want to look at later. But I want to kind of drag this thing into, or bring it into my project. And the way to do that is you can actually drag and drop an image like this one into your project. By the way, for those people who can't generate what I just did, I'm going to take this image, right? And here's Slack. I'm going to go to Developer. I'm just going to drag and drop this image onto Slack. And now you guys have it. There you go. Grab that image off of Slack. So if you want to do what I did, right? Okay, so let's go back over here. That's why Slack is awesome. So if I want to drag this onto my project, I need to access it from a solution perspective. So here's my project. And notice that there's properties and references. So how do I do that? Well, what I need to do is go to Project. This is the right thing to do. And if I go to the project name, so in this case, it's COMP1004, W2017, Lesson 3, Properties, the project properties down here. So project properties. Notice that I can also go to things like resources. And if I look at resources, I can go to, these are string resources in here. And this is the name of the string. Why would I want to put string resources in here? Anybody? Localization, right? I want to store all of my string resources in here, all my French names, all my Spanish names. I'm going to put all those strings in there, like for example, Spanish button, Spanish next button, English next button, and so on. And a lot of times we put all our localization in strings because I can refer to them, and if it's English, then change it to the string that I got here, right? As opposed to hard coding it inside of your code. This is easier, and it keeps track. It's almost like an array of strings. But what I really want to do is I want to move from strings, you can see the down arrow, to images, right? Strings to images. And now that I got this open, so I went to Project, Properties, and then from Properties I went to Resources, and I changed from string to images. That's what I did. And now what I can do is I can add it, or the thing is, which is right here. I'm just going to pull it so I can see it. There it is. I can just drag and drop. Microsoft allows you to do that, drag and drop stuff, right? Once I've dragged and dropped over here, notice that it's over here too. Inside my Solution Explorer, it comes under a special resources folder, right? Resources folder, and it actually gets copied into my project. This is the way to do it. I don't want to load my resources randomly from some place. I want to kind of have it here in my resources. And if it's not showing in your resources, then you can't use it. You can't reference it. We're going to talk about how to reference things by code later on, right? But for now, I recommend you do it this way. Now, if I go back to my calculator form designer, I want to have my calculator itself point to my form. And if I did things correctly, and I may not have, all right, we calculated 300 by 90, right? Give me a little bit of buffer. Kind of, you know, point to it. I should be able to click the arrow, click choose image, and then pick from my resources like this and press OK. And if I did everything right, it should look nice, right? Now, why did I to go through all this? Because you know what? People don't know how to how to put together their picture box. These are all the steps that I would do. If I was going to use a picture box, I'd make sure that I would balance it, that I wouldn't use some kind of stretch control, that I wouldn't use zoom. I would make sure that it's the exact size that I need, so it fits exactly in my user interface. Okay, this is absolute layout. When there might be other courses that do, you know, some kind of responsive layout, and this would be different then. Here's something. It's called Picture Box 1. What should I call it? Is Picture Box 1 the right name for my object? Hell no. It should be called something like Logo Picture Box, right? Because that's what it is. So I'm going to call this Logo Picture Box. I may not have a need to refer to it in code, but it's always nice to name everything properly. Okay, great. I added my logo. I added my logo picture box. Guess what I'm going to do? Commit. So team, I'm going to go to home. I'm going to go to changes, right? This is what I should do. Every time I add a feature, here's all the things I just changed. I'm going to go here. I'm going to say added logo, right? And commit all. Save everything. Home, sync, and push. And now you guys have the logo online. If you didn't get it from Slack, you can get it online if you're remote. Let's check it out and see if it works now. What if it didn't work, right? What if it doesn't look right? It looks okay. A little bit of a margin there. I'm not really happy with that. I can probably nudge it over a bit, right? I'll be honest with you. Probably just a little bit because I see a little bit of white space on the side. I mean, without being too finicky. I think I'm being a little finicky when I say this, by the way. But I don't think it's negative if I went kind of just nudged it over a little bit and tried it again, right? Now, one more. And again, I do that because from a balance perspective, I want to make sure that the same from one side or the other, right? That's better. To me, that's more balanced. You can see that there's both equal amount of white space on the left side and the right side, in my case. Questions around this picture box? Nice and easy, right? Guys and girls, you know, I mean, when you kind of put together this, you know, your user interfaces here, they're not that difficult to put together. Oh, we have a problem here still, right? It's just around trying to balance what you see here in your project. Let's take a look at some of these PowerPoints now, because I want to kind of cover some of this. I covered some of the code. I want to get back to it next week again. I know I'm kind of going and extracted. I'm kind of really pushing this calculator example and then the analogy forward. But I want to keep doing it because there's lots of little parts that you may not understand, and I don't want to lose anybody. One of the questions I asked during the break was, why did I use the this keyword, right? Why do I use the this keyword here and be so explicit? And the question is also, do I have to do it? Should I, or do I need to do this here? What's the answer? If I want to say, do I need to do it, does C# require me to use this? The this, lexical this, huh? It doesn't. In fact, it grays it out. Take a look. It's grayed out. I'm using it because I want to be explicit here, not because I have to be. One other person asked me during break, hey, how come, Tom, you kind of told us that private, that this is like an event handler, and it should be kind of private, and then all private stuff should be an underscore. Shouldn't we change the name of this thing in your new convention to kind of make it an underscore? And the answer is, yeah, you should. Right? You should make everything the same. All private instance, methods and instance variables should use the same convention if we're going to make them private. Which means I need to rename this thing, and I want to do it through code. I don't want to just type it, right? So I'm going to right-click, and I want to rename this thing. So I'm going to go refactor, rename, or rename up here. So Control-R twice, right? And then just kind of retype what I want in there. So when I kind of go to this, the capital to the lowercase, and kind of go under it like this. And now it's going to rename it and refactor it all over the place. So even in my code, it's not going to break my design. It's not going to sit there and go, hey, I don't know what that is. Oh no, I don't have an access. Remember, because even if I go here now to my events, which I showed you guys last week, I can see that my click event for these ones goes to that underscore calculator button click. Is it ugly? Yeah. but it should be, because it's telling you that the calculator button method, I'm just going to close this off, method is private. Calculator button click method, right? That's what it is. It's not public. It's not publicly available somewhere else. I can't invoke the calculator button click method outside of this class. So therefore, I should rename it properly. Questions around that? So some stuff we did here that was kind of cool. Still got lots of work to do and lots of things to talk about next week. Let's continue with what I'm going to be talking about here, which is my PowerPoints. I'm going to skim through these things. I'm going to kind of give them a glancing blow. I'm not going to talk too much in detail here because they're self-explanatory. They're excerpts from the book, and I'm using them as reference material, background material for you guys, just so that you're able to go through. And if there's something that you're missing, these things will hang back and give you that. So again, one is, we talked about this, how to work with numeric and string data. This is a good one. Let's take a look at this one. And this is up online, up on Blackboard for you guys, right? Now there's 55 slides here. If I did 1 minute per slide, we'd be over time, right? And there's probably 55 slides on the other one, like I said, right? So I'm going to kind of hit the highlights, which means I'm going to skip through some of these. All right. These are just the objectives and the knowledge that you need. Different kinds of built-in types, the same built-in types that you've seen in other C influenced languages, specifically in the .NET framework, same ones that you'll see in VB, maybe a little bit different in C++. You would need a char or car, C-H-A-R, variable here instead of a byte, right? And what is a byte? How big is a byte? How many bits in a byte? Anyone remember? 8? How about in an S byte? How many bits in a byte? What's S byte stand for? Signed byte, signed integer. Integer 16. Typically when we use integers, unfortunately, we use integer 32. That's the default integer type, right? If I go integer, it's integer 32. That's the .NET type. And that means they're massive integers. And these are signed integers. Sometimes you don't have to use these. And for the most part, in rapid application development, I'm not going to be heavy on them, right? But if you're trying to do memory management and all that kind of stuff, especially if you're making a game or something that's going to take a lot of memory, or there might be a memory leak, we may have extra information here or extra space to hold our data, but we don't need to, right? So we can choose other kinds of types. I'm not going to go into too much about this. There's longs and U-longs, unsigned long, floats and doubles. By default, we want to use doubles. That's what we want to use by default, double precision. And if we're going to use things like numbers, like when we're talking about currency, I want to use decimals. Okay, please use your decimals for currency. It's the better way to go. Here's char again. Are you good with that? Well, I recommend decimals for, especially for calculations for for more precision. All right, I'm not going to go too much into how to declare variables. You guys know how to do that. That's what's all in here about how to declare variables. Arithmetic operators, same as C-style or C-influenced languages. There's also these operators, these increment and decrement operators, which, by the way, are deprecated, believe it or not, in Swift, the Swift programming language, right? From that Apple came out with. They don't want those, right? Again, Apple's always a little different. And there's always, we also talked about so I'm not going to go through this, the shortcut operators. These are the shortcut operators with plus equals, minus equals. We actually used these already when we made our calculator. We did plus equals, which is the same as saying this is equal to this plus something else, right? And I'm not saying the keyword this when I say that. All right, and that's the kind of stuff that this PowerPoint goes through. So I'm not going to go into detail about how to create basic variables. They're here, and it's very, very kind of intuitive. If you've done Java before or any other language, then all this stuff becomes a little bit clearer. Here's something that you want to know. The math class, if you want to add some special effects to your, or special functions to my calculator, then I'd probably use built-in functions like math square root. And why would I write the square root function on my own? For the most part, I wouldn't have to. This. And here's the argument. Is this more efficient than making my own, right? Which one's more efficient? And if I'm doing a lot of square root calculations, sometimes my own is a little better. Why? Because I'm referencing the math library here, right? Where I don't need to. I can figure out square root on my own sometimes, right? Now, square root, it makes sense. Power, though, to the power of, definitely you can make it easier for yourself, right? Because power is if I put, a number to the power of something else, so a number to the power of something, that's how many times I iterate. And you can do a lot of things to make that effective. Although I have to say, for the most part, most math functions, and for our purposes here in rapid application development, it's okay to use math functions. I'm not going to get down on you which is more effective. I'm just talking about general programming principles, right? Yes, of course, right? But the one thing you don't want to do is any kind of evaluation on the calculator. That will break my requirements, right? So math that round, square root, minimum, maximum. Those are really good. Initialize strings. Okay, so remember I did this already. I kind of initialized the string with a double quotes, and again, in most C-influenced languages, that means the empty string. It's also good if you wanted to do something like use null or the double quotes. What's the difference between null and double quotes? Are they the same? Is null and double quotes? No, one is an empty string, and the other one is null, non-initialized, and that's a different thing between the two things. So please be careful. That's not the same. Into trouble when I talk about comparing strings. String comparison is always, kind of a break point for us. We kind of think about how do we compare strings, and we'll talk about that in a second. Escape characters, same as other C-influenced languages. If you know backslash n would be the new line, and all these other backslash escape character would allow you to do stuff there. So nothing different there. Keep on going for other examples. I'm not going to talk about value types. We've already talked about now capital S string and capital O object. That's a reference to a string object or a string or an object type. That's different than lowercase s, right? And lowercase, well, there's no lowercase object, so lowercase s would be totally different than the capital S, right? We talked about the toString method today. toString method is kind of built into every method, just like it is in Java. I also want you to think about the difference between parse and tryparse, right? And there's a difference here. Tryparse actually almost takes the place of some kind of exception handling. It kind of tries to parse the string, and it returns a result, right? And if you think about what it does, the result, it stores the value. So it says a static method that converts the specified string to an equivalent data value and stores it in the result variable. This is the result variable. Huh? Well, how can that be? It means I got to put a result variable in, and I got to somehow I get something out. And I want to talk about this tryparse later on. So keep an eye on this one, parse and tryparse. And there's also convert. And I think the convert class is very useful. So you have to put convert, capital C, convert. That's the convert class. And then dot, 2 decimal, 2 double, 2 int, 2 char, and so on. That's a very, very useful class. So you can convert something toString that doesn't have the toString method attached to it for whatever reason, right, if you really wanted to. Or if I wanted to convert back, like in your assignment number 1, if I want to convert back to decimal, right, or back to string, I could do that. Or I can convert to decimal from string this way by going convert to decimal, and then it converts the data type. That's the way I want you to do it. I don't want you to use the other methods. There's also to double, and there's also if you have a float, for whatever reason, if you're using float instead of double, it would be to single. All right, for those people, it's not listed here, but that's what the conversion would be. All right, and there's some examples of parse and tryparse. Here's a tryparse example. So here's decimal tryparse. So I want to try and convert my sales string to decimal, and I'm using this sales. Remember, it has to go into the sales object, but now I have this modifier out. Does anyone remember? Is there an out in when it comes to Java? Does Java have an out? What does out mean? It's a reference type. So what I'm actually doing is I'm saying, hey, when I create this decimal sales, notice that I'm using the M. I also have these modifiers, right? If I'm using a decimal, it's M. If I'm using a float, it's F, right? If I'm using a double, it's nothing. I don't have to specify. By default, it's a double, right? Like I said. But here, if you notice, I'm using this out keyword with sales, which means I want to use sales as a reference variable. So when I can make the conversion, I store the result in this variable without an equals operator. That's a different form. And I want to put it out to you. Is using pass by reference a good practice all the time? And the answer is most of the time no. But in this case, it makes sense. And you're going to see this syntax with C# a lot, out and a variable, not just here, but also in places like OpenGL, if we're going to do C# with OpenGL, with Unity, if you're going to build a game with Unity, you're going to see this out methodology a lot, where we refer to the variable that we're going to output to. I want you to think about that as the variable where the result is going to go to, the out variable, right? Which in this case is called sales. Okay, so that's kind of a new thing that you may have not seen before. And some other examples of converting. And like I said, the numeric formatting code's very important to kind of put in here. C for currency. What does this mean? Well, when I convert to string, right? Here's an example, convert to string. And if I put C, not only does it convert to string, but also adds the $, right? But here's a problem. If I convert to string and add a $, and convert back, what do I got in the string? A $. Yeah, be careful. That means I got to strip that $, out. Because if I try and convert a $, it's going to fail every time, because there is no $, in decimals, right? $, is a string value that we like to see on the user interface side. But if we convert back, you're going to have an error. So if you ever get an error by converting a decimal that's got a $, in it back to string, that's the reason. And same thing with interest. Look, it says P for percent with 1 significant digit. That's what this means, right? And notice that it says N0, N0. And if you look at what it says here, N is a number with 0 significant digits. That's what this means. So there's just all the significant digits after here. There's nothing, no decimal afterwards. And here there's 3 significant digits, rounded to 3, right? So these are important things. That's why I'm pointing them out in the PowerPoint presentation. I'm not trying to bore you. You're going to need this for assignment number 1. And that's why I put up these PowerPoints for you guys, because when you convert and display dollars on your user interface, they've got to look like dollars, right? Or, I don't know, if you're converting them to yen, right, as an example, they got to look like yen. And there's a way of doing that with localization. You need to research if you want those extra bonus marks. Okay. Kind of went through this. Also, this is very important, the syntax of the format code, because the format code tells C# what kind of data type you're using, so it's not confused, it's not ambiguous. Okay. Here, the last parts, it talks about scope, right? And also things like how to use built-in enumeration for things like form border style. If you go form border style dot, then it'll give you some examples: fixed dialog, fixed single, sizable. So this is the way you can modify the actual form properties within code. And I want you to also think like this: if you can do it in design mode, you can do it on the programming side, right? So if there's a property right here in the code, so if I go back to my solution, and if I look at my design side, and I can look at any one of these buttons, let's say the C button, if there's a property that you can see here that I can change, I can use the exact same property in my code, the exact same name, almost the exact same thing, right? And that's always a hint. If you want to do something programmatic to affect the form somehow, look at your property list first, and that'll give you a hint of what to do. It's not always exactly the same. Sometimes there's a modification here or there. For example, in color, you need to assign a new color as opposed to assign a color, by name. But but you can see it's pretty intuitive. Okay, so that's what this is all about. I'm just going to run through the next piece. Enumerations. Anyone ever not know what an enum is? Enum. And some people, this is confusing to some people. I want you to always think of an enum as a really quick type, right? Where you want to kind of, instead of using a value like 0, 1, 2, 3, 4, sometimes we do that. We say, okay, if it's type 0, if the state of our calculator is 0, that means, that's another way to do it, you can make a state machine that says, if the state is 0, then it's not clear. If its state is 1, then we're ready to go. But 1 and 0 don't mean anything, and you can use an enumeration to add a word that means something, but still retain the integer on the back end, where 0 and 1 means something, right? So that's what enumerations are for. We're going to talk about that later in the course, right? And here's some examples. We're going to come back to this to create some enumerations later, right? So this PowerPoint is really all about data and types. Oh, this is interesting. The question mark, it means a nullable type, or if you will, it's an optional, right? Am I going to get you to do this kind of stuff? Hell no, right? Because it can be quite confusing. This is more an advanced, state of being. But you might see this in COMP 2007 in the summer when we do enterprise computing, where you have some of these question marks. And question marks a lot of time mean it's optional. We'll talk about that. And they give you some examples about the invoice form kind of stuff here. Okay, so we're not going to talk about too much more in this PowerPoint. And we only have a few minutes left, and I want to talk about the second PowerPoint. Again, this is just reference for you guys, right? So you can talk about what this stuff is all about, right? Control structures. Now we talked about some of the control structures today. We talked about the switch case control structure. Here's something. Notice that the double equals here is equality. Now, if you're used to something like JavaScript, JavaScript also has triple equals. And triple equals in JavaScript means exactly equal to, same type and same value, right? Here we don't have that in C# because C# is a strictly typed language. So we assume that both sides are the same, okay, that you're comparing. Now the problem goes when you try and do equality operators or comparing things like first name like this, right, where your first name is a string and you're comparing it to a string literal. Sometimes, I'm just going to put it out there, because it's a string and a string is an array of characters, you get into trouble where it's not doesn't match. All right, especially when it comes to converting something from the user interface back to code and then comparing strings. Like your text, we assume that the text property of a user interface is a string. Sometimes we can't make that assumption depending on what we're doing. String in order for us to make this comparison, this equals comparison. Just, you know, be wary of that, right? Now, this is where we combine logical operators. If I go and or, conditional and, conditional or, conditional not, we've done these before in other C# languages. What's the difference between a single and a single or? That's a little different, right? Why use double and double or as opposed to and or? Well, these ones don't exactly do what you think. These ones almost like do bitwise operations. So be very careful about using single and single or. Okay, use these ones. And we'll talk more about that again as we move into the course and get more crazy. Here's something that's really bad. Do I ever want you to code an if statement like this? Hell no, this is wrong. I would never do this. And people have, again, there's two camps on this. If you're a C++ programmer, you're going to say, this is okay, because I want to make tight code. I don't want to need the curly braces. Curly braces are extra. Please use the curly braces, because why? I may only have one statement inside the condition, right? But what if I add another one and I put it underneath? I might think that it's part of the same code block, even if I space it nicely, but it's not. All it refers to is this first statement, and the second statement is ignored. And so you would get a systematic error, not a syntax error. So based on what you're doing, almost like a procedural error, more than it's a bug more than anything else. So please don't do this. Always use curly braces with if statements, okay? And same with this. This is really bad code. Now the book does this a lot, and they do this because they want to give a tight example coding style, and I don't recommend it, okay? Again, another 30 pages on this thing. Nested if, we did the switch case statement. Notice that there is a default I talked about today. We didn't use the default case, but it's a good practice. I could have used the default case instead of putting the other in the tag. I could have done that. It would have been the same result. And we're going to talk about that. Why would I use default? Why would I want to tag it as other? Is there an advantage? There is to using the tags, right? But sometimes we want to use the default case just in case. It's kind of the catch-all case, just in case these two cases or these multiple cases don't work. And some languages, you're required to put the default case. You can't not leave it out, okay? Just putting it out there. And there's some examples of how to do that. One thing you can't switch a statement like an if statement. You can't, kind of calculate a result in the switch. So be aware of that. Some people try and do that. They go case, case if blah 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 blah. No, you can't do that. It's just literal. You're looking at a value of a of a variable, and then you're switching the it's almost like you're doing an if else if else if else. Okay, that's what you're doing there. These are all control structures that you've seen before. The while loop, same as in Java, very, very similar. You can see that. Now, for the while loop, you need a sentinel variable. Sentinel variable means that if there's something that's got to break the loop, right? Because a for loop is more controlled, you have that sentinel variable in it. Starts and ends, a range, if you will. While loop doesn't have that. It'll run forever if you don't have a sentinel variable to catch it and stop it from running, right? It'll create an infinite loop. Do while. This runs at least once, a do while, where a while may not run. That's the difference between a do while and a while. Again, a little bit of a review for you guys, and I know I'm going fast. For loop is the most common loop that we use because it's easy. But when we use things for arrays, which we're going to get into later on, we want to probably use a for each. which is probably a better structure for an array. We don't have it here. And we'll get that later on. So looping structures. I'm not going to talk too much about breakpoints at this point, and the rest is pretty much stuff we've covered, all right? So that's what these two PowerPoints are. They just kind of talk about a little bit of C# code if you don't know how to do syntax. Remember next week, when is your assignment 1 due? Is it due to class? No, right? It's due the day before class, right? So if you get it, if you come into class and you're working on it, then you missed your due date, right? That means you've lost 20% of your mark. Why would you do that? Get her done by Sunday at midnight, right? I'm also going to try and remember to put a little bit of a reminder up on Blackboard and Slack to say, guys, your assignment 1 is due by midnight, and still people are going to be late, guaranteed. Any questions before we go? Okay, can we talk after? Guys, thank you so much, and I'll see you next week. It's almost like I don't see you enough. I feel like I want to see you more. It is what it is. If you want to make time with me, please book some time, okay? Thank you. I'll come back to you as well.